So this is page 176, number 5, that a student was asking about. It asks for the power output of the motor. Okay, so we want to find the power. So this student found the force of, or found the mass, so took 700 newtons, found the mass. I like that, that's creative. So found the mass. Then they found the kinetic energy, so how fast it was moving. I wonder if that works. I'll come back to this work and we'll see if there's maybe a strategy there for us to actually get to the end answer. But we'll first look at kind of why this question's at the end. So at first it seems like it's a relatively straightforward question, but it is at the end of the assignment because it is a little bit deeper. We know power is work over time. Now work, so we know power is work over time. Work is the same as force times distance, and that is over time. Now if you look at that equation, I wonder if there's anything that stands out to you. Maybe this does. Right, so we have power is equal to force times distance over time, if we play around with that equation. And distance over time, we know, is the same as speed. So power is equal to force times speed. Now, we don't have a formula for that, but we can kind of see that if we play around with that equation. So this question is really, like, the calculation is relatively straightforward. 700 newtons times 2.0 meters per second. And I end up getting 1400 or 1.4 kilowatts. So I did pause the video and look back at this work to see if there was a way to get there to this 1.4 kilowatts, but I don't really see it. Because we found the mass, which is creative, found kinetic energy, that's creative. But the problem, I think, is maybe because it's moving at a constant velocity, so that belt is doing work to maintain that energy. Yeah, so I think down here is the thinking that we want. So we understand that a watt is force times distance, and then we have that distance over time, which we have here is our velocity. So we can come up with this equation. Now, it's not one you have to memorize, but we're able to rearrange equations, and then we get 1.4 kilowatts.